Hi to all the Form 5 students, how are you now? I feel sorry that we can't meet each other during this month due to the MCO, the Movement Control Orders, but it's for the good of our future. So hopefully we have a better tomorrow. All the best, Malaysia. So come back to this. So in order for me to teach you and keep you on track of learning, so I prepare this kind of a slide, the video slide for you to learn. So I will teach you topic by topic, but not the whole chapter in one shot. No worry, I do subtopic by subtopic, referring to your monthly notes. So the first of all, today I'm going to start with your February notes. If you still have it with you, that's good for you. Refer to the notes and you turn to the page number 4. This is what we call as a potential difference. So today I'm going to start with discussion with you what is a potential difference. In Malay, they call it as a beza keupayaan. So what is a potential difference? First of all, the symbol that we use is called a V because potential difference beza keupayaan juga dinamakan sebagai voltage. That's the reason why, as you can see from here, we are using V as a symbol. And again, I'm very sorry. I know. This is the 4th time you see the V. For some, you see it's called the velocity. Then we have a volume. Then we have a image distance. Now we have a voltage. As you know, physics, we have one problem that we're not able to solve until today, which is we don't have enough alphabet. Sorry to say, no choice. And the more confusing part is, the unit is also V because it's volt. Volt is the name of the scientist. His name called Voltaire. So he used his name as a unit. So that means that if you see something like V equals to 2V, for example, so what it means? That means that voltage is 2 volt. And you don't be so silly going to cut the V away. No. This particular V over here is the symbol. And this is called a unit. It's two different things. Don't cut away. Don't cut. Okay? Next, the definition is referring to the energy needed to transfer one coulomb of charge. What I mean by that? As I told you before, charges, or we call it as an electron, is calculated by a coulomb. So do remember, one coulomb containing how many electrons? A coulomb means a group of electrons. How many are there? Okay, still remember, that's good for you, which is 6.25 multiplied by 10 powered by 18 of electron. That's a group. So you might understand that electron is a particle. When you want to move particle, a group of particles from one to another, you need energy to do that. So that is the idea of the voltage. So let me show you by using example that's much more easier for you. Imagine that if I have a voltage of 10 volts. What do you mean by that? Imagine that you have a one coulomb of charge. Just one coulomb means one group. You want to transfer it from one place to another. What you need to do? You need to use energy. And how much energy you need? Because you're using 10 volt. That means you need how much energy you need? You need 10 joule of energy to do this process. That's the idea of the 10 volt. Same thing. If I have a voltage of 20 volt, what it means? That means that for me to transfer one coulomb of charge from one to another, how much energy I need to use? Yes, you are right. That will be a 20 joule. So that's the idea for that. And obviously, if I have a voltage, for example, is 1000 volt, that means that in one coulomb, I want to transfer it, I will need to use energy as much as 1000 joule. You got the idea? Very good. So from those ideas, you can see one important thing is the higher voltage actually doesn't mean a good sign, because higher voltage means you need more energy to transfer a charge, which is the same quantity of charge we're referring here is one coulomb only. So that means that lower voltage means you need lower energy to do the same job. What is the job? To move one coulomb electron. Like 1000 volt, you need 1000 joule to move one coulomb of electron. So that is not a good thing. That means a good power supply, always remember, lower voltage, lower potential difference, always the best. Let me show you more example by referring to the next empty slide. So imagine one more time if the voltage is equivalent with 10 volt. That means that every one column you want to transfer, you need how much energy you need, which is 10 joule. Am I right? Very well. How about same thing, imagine I'm still using 10 volt, but now I'm going to transfer 10 column of charge. Remember, a column actually is a quantity of electron. One column means one group. 10 column means 10 groups of electron. Definitely and logically, you need to transfer more electron. You need you need more energy. So logically, how much energy you need? Yes, you are right. You need 100 joule, right? Let's say I have a 1000 column to transfer that. So how much energy I need to use? Very good. That will be a 10,000. Okay, 10,000 joule energy to this process. On the other hand, let's imagine if let's say the charges that I need to transfer is lesser now. It's a zero point 0.1 column only. We should not even come to 1. So how much energy I need? Very good. Technically, you just need 1 joule only. Am I right? So from all this example, you will see one magical relationship between three important things, which is number one, potential difference, voltage. Number two is the charge, which use a Q as a symbol. And the third thing is called the energy. Energy in general, we use an E as a symbol. So from all this example, what you will see, how we know this is a 10,000, 110, or even a 1 over here? How we know all those values? So basically, as you can see from here, all this energy value is basically you are taking the value of the V, which is the voltage originally, multiply with the Q, means the charges quantity. So that comes to our formula of calculating electrical energy. And this electrical energy is related with two important things, the V and the Q. But do remember, from previously we have a Q equal with IT, which is a current and the time. So as a result, energy also can be write as VIT. So there are different form of method of writing the formula. Obviously, how to use the formula we will discuss with you in the next slide. So in this video, I just want you to understand the basic idea of the voltage, charges, and the energy. For the next slide, I will continue with you in more detail how we going to apply on it by showing you some example of calculation. So I hope you enjoy this. I will see you in the next video. Take care everyone and stay strong, stay healthy. Bye-bye. So sekarang kita akan masuk kepada satu subtopik yang baru. We are still in chapter 2, masih dalam bab yang kedua. Dan the title of this subtopic is called electromotive force, short form EMF. Dalam bahasa Melayu kita namakan sebagai daya gerak elektrik DGE. Okay, and this is considered almost the end of chapter 2. And this part I call it as a part 1 lah. Bahagian pertama, nota yang baru, muka surat yang ke-7. Okay, so what is actually electromotive force? Let's look at the next slide. Let's look at the definition for the electromotive force. Electromotive force, or EMF, okay, E of a dry cell is a total energy, electrical energy given to one column of charge to flow through the cell in the open circuit through the terminal. And I don't think you understand what is this. This is a very standard definition of it. So let's look at Malay definition. Daya gerak elektrik DGE untuk satu sel kering adalah jumlah tenaga yang diperlukan untuk memindah caj sebanyak satu kolom melalui litar terbuka dari satu terminal ke satu terminal lain. And I don't think you understand it as well. Am I right? Okay, good. Never mind. It's okay. I will make you to understand what's going on. Let's look at the next one first. I'll show you what happened. First of all, just introduce you the symbol that we use to represent the EMF. Okay, or electromotive force, DGE. We use a capital letter E or this thing over here. Alright, so it looks like E, yeah, but it's a very rounded and artistic E lah. So a lot of time they use either capital, okay, they use a capital E or this type of E lah. So that make a difference because E also is kind of confusing. Dia juga merupakan simbol tenaga, energy. And what else we have? Unit dia volt. So is it good? Price is a price. So now the conclusion is, what is actually DGE? Okay, ataupun EMF. Actually, for your information, EMF, potential difference. Oops, why like that, huh? And also another one called voltage. Basically, they are all the same. EMF is a type of voltage also. But what's so special, we have another term for it. Okay, let me show you what is happening now. Because EMF actually is a voltage that we apply on a battery. Okay, on a battery. So why we say that, let me explain to you now. So first of all, battery, this is called a positive terminal. This is what we call as a negative terminal. So what is going on with the positive and what is going on with the negative over here? So seperti yang kita tahu bahawa negatif maksudnya adalah tempat yang mempunyai banyak elektron. So electron actually will accumulate at this area. Dia akan berkumpul di sinilah. Just imagine all the charges, all the electron will just, okay, stay there, okay, just waiting for the moment to come. So apabila kita cuba sambungkan satu litar, when I try to connect with the circuit, what is happening now? Let's say with a resistor. So because of the electron, right, actually is moving from a negative terminal to the positive. So that means that electron is coming out from here. Electron is coming out. Imagine they will come here, they will go here, so they will go here, and they will go here, and they will come to here to complete the circuit. So electron is going to move like this. And of course, right, I want you to understand now, when electron is able to complete the circuit, then it's something going to move at the opposite direction. Okay, electron is moving from the negative to the positive. So what is going on after that is the current is going to move from the positive to the negative. But today's discussion, I'm not looking at the current, I look at the electron flow. Alright, so just focus back to the electron now. So imagine electron is completing the circuit, okay, from the negative to the positive, we flow to the resistor. Okay, and because of that, this resistor actually is getting a value of voltage from the battery. The value of voltage from the battery. Remember, this resistor is only receive the voltage when the electron completing the circuit. Apabila elektron akan melengkapkan litar, iaitu elektron berjaya beralih ke positif terminal, maka barulah kamu boleh nampak, barulah kita kata, okay, ada satu voltan yang berlaku pada resistor. Ataupun kamu bayangkan kalau resistor ini ditukarkan, okay, digantikan dengan satu light bulb. So apa berlaku apabila kita letak satu light bulb ini akan menyala lah. Bermakna satu voltan akan melepasi atau melalui light bulb ini. Okay, that's the first thing. But do remember, because this is what happened in a battery. Remember, electron is always on the move from the negative to positive. So what the electron will do after that? So after that electron from here, right, some of the electron, I would say the minority electron, it will flow internally to the positive terminal, just like that. So electron will go in internally like this. So when electron is able to complete the circuit again, dia mampu melengkapkan litar, bermakna satu lagi voltan akan dihasilkan di dalam. So untuk membezakan ada dua jenis voltan ini sekarang, satu yang berlaku kat dalam, satu berlaku di luar. So yang di dalam kita namakannya sebagai voltan dalaman, internal voltage, Vin. So yang ini adalah mengalir di luar, so voltan luaran, external voltage. Now you can see that we got two types of voltage now, okay, in the circuit. So now come back to the basic. What is EMF actually is? EMF sebenarnya merupakan voltan juga. Tapi voltan ini adalah sebenarnya adalah gabungan daripada voltan mengalir di luar campur dengan voltan yang mengalir di dalam. So this is what we call EMF. It's a two-in-one, I would say. It's a two-in-one. So basically, outside plus inside is equal with the EMF. EMF is the total voltage for the entire battery. Is that clear? I think it's kind of easy, right? Alright, so I will stop here. I see you again in the next round. Hai, selamat kembali. Ini merupakan bahagian kedua untuk diagonal electric DGE. English, we call it as electromotive force, EMF, part 2. Okay, this is basically another video for you to understand better what is actually means by EMF. Okay, this part actually basically I just want to show you how we can measure the EMF and also external voltage and as well as the internal voltage. How we can do that? We have referred to this particular circuit. So untuk letak ini, untuk kita nak mengukurkan EMF, remember we're going to find three things out of the circuit. Number one, we need to find the EMF. Number two, we need to find the external voltage of the circuit. Number three is the internal, whatever the flow inside the battery. Okay, first of all, you need this kind of a circuit arrangement, di mana kamu memerlukan satu voltmeter yang disambung secara selari dengan battery. Selari means there's another wire connection over here. After that, outside the circuit, you need a resistor. Kalau you tak nak resistor, you can use a light bulb also can. Okay, satu mentor pun boleh. Imagine you draw a light bulb over here. Also can. But this is very important. This is a switch. And this is very important in a circuit. You must have a switch. Because the switch actually will able to tell us what's going on with the circuit. So, apa maksud saya di sini? Okay, let me use another color. So that easier to understand. So, the most important key of this whole circuit is a switch. Okay, first of all, imagine when the switch is off, apabila switch is off, okay, what is going to happen to the voltmeter reading? Okay, remember, walaupun lita ini adalah off, okay, bacaan voltmeter sebenarnya masih wujud. That means that you still can get the reading from the voltmeter. Okay, you still can find the reading for the voltmeter, although walaupun dia adalah off. So, bacaan yang kamu dapat dari voltmeter is called the EMF, the DGE. Okay, katakan apabila lita ini off, you get a DGE. Katakan bacaan dia adalah 1.5 volt, katakan. And that is actually equivalent with the DGE. Okay, diagonal electric or EMF. But imagine the moment you turn on the circuit, you know what happened? Immediately, secara terus, bacaan voltmeter. Okay, the voltmeter reading actually immediately it will change. Okay, dia akan berubah serta-merta. Dia akan menjadi satu nilai yang lebih kecil sebenarnya. Is representing the external voltage. Representing the external voltage. Okay, so itu maksudnya. So, disebabkan kamu akan dapati, ini adalah satu nilai yang lebih tinggi. Ini adalah satu nilai yang lebih rendah. So, apabila kita gabungkan dua nilai ini, iaitu kita ambil nilai lebih besar minus nilai lebih kecil, you akan dapat satu nilai yang baru. Dan nilai baru itu, kita namakannya sebagai the internal voltage. Okay, it's called the internal voltage. Okay, and that's how it come across with that. So to understand this better, let me continue. I need more space to do what we call explanation for you. Let's look at the next one. Imagine just now I already mentioned it to you. EMF basically is, okay, external. Why the color change? Is it a white? Still white, right? Okay. Oops, sorry. I should not write like this. My fault. So from the previous is minus the external, you will get something called as an internal. And because of that, kita rearrange it, EMF menjadi external plus with the internal. So this is how we come across. But do remember one thing, V is always equal with the IR. Disebabkan R ini adalah disambung di luar. So bermakna this must be the external as well. Oops, sorry. So this must be the external as well. So bermakna you akan dapati EMF is equivalent with I capital letter R, which is the external, campur dengan I small r. So what does that means? The R actually yang besar kita namakannya sebagai external resistance. Okay, rintangan luar. R kecil dinamakan sebagai internal resistance. Okay, rintangan dalam. Okay, bermakna apa yang berlaku di dalam bateri. So that's the difference. So of course we can try to rearrange this, becoming this is equivalent. Factorize the I, you're becoming the R plus beta R. So that is a formula that we can use to do the calculation. Understand? So that is a main idea of the EMF. So how to apply the formula, I will discuss with you in the next video. Okay, see you then. Okay, I'll see you again in the next video. Bye-bye. Hi, this is electro multiforce EMF diagonal electric DGE part 3. So basically this is nothing much. I just want to show you some example. Macam mana kita nak gunakan formula, how we can apply the formula lah. Okay, that we already show you in the last 2 video. So let's look at it. So basically this is an exercise you can find from the notes on the page number 8, muka surat ke-8. So you have the notes with you, that's good. We're going to do it together. Okay, this is a question we have. So diagram above, okay, so let me just change my pen color first. Okay, diagram above actually is not above because I already rearranged it. Show when the switch is off, this is very important. The voltmeter reading is 1.5. Stop reading from that. So apabila di bacaan, okay, voltmeter, okay, adalah 1.5 semasa off. From the previous video as I told you already, semasa di off, bacaan voltmeter adalah mewakili apa? They're going to represent the EMF. So bermakna EMF actually is 1.5 volt. Okay? When the switch is on, apabila hidup, voltmeter become 1.35. Bermakna this external actually is 1.35 volt. Secara tidak langsung, we can get something for free. Very important or not, we can get an internal voltage, which is EMF minus this, you get 0.15 volt. And the voltmeter and the ammeter shows 0.3 ampere. So bermakna the current flow is equivalent with 0.3 ampere. Find the internal resistance, maksudnya carikan R. Macam mana? I want you to understand the formula for the EMF basically is a external plus with the internal. But it doesn't mean that all the time we're going to use the whole formula. Tidak bermakna setiap kali kita gunakan keseluruhan formula. Sebab formula ini boleh digunakan sebagai IR campur dengan IR juga. Di mana saya nak cuba tunjukkan kepada anda adalah kamu juga boleh menggunakan bahagian ini sahaja dalam formula. Sebab mereka ada sama. Same thing, we can also use this part of the formula only to do it. That means that basically the internal voltage is also equal with I small r. So this is our 0.15 as we calculated earlier on. And this is a 0.3. So R we need to find. So in that case, I don't think it's difficult for you. So R going to be 0.15 divided by 0.3. So obviously you will get a 0.5 ohm. So that is the final answer for this question. Alright, next one. Okay, what you're going to have from here? A cell with an internal resistance. Okay, that means that it's an internal resistance. Okay, it means it's a small r, equivalent with 2 ohm. Potential difference from the cell with the external terminal. Potential difference of the cell. Okay, that means that is the external voltage, which is equivalent with 2.4 volt. And the current flow, okay, arus mengalir 0.3 ampere. So apa dia nak? EMF. So EMF sama dengan external plus with the internal. So external 2.4, internal is I small r. So they're going to be 2.4 campur 0.3, R is 2. Senang kan? So use your calculator, you will get a final answer, 3 volt. Alright, I think red pen is a bit hard to read, so I'm very sorry for that. I will use a white pen in the next question. So now you can see. Okay, what is happening? A dry cell with a EMF of 3 volt, internal resistance of 0. Oops, sorry. Erase all this. So gonna be oops, where is my pen? I can't see the pen. Okay, 0.5 ampere connected to resistor R ohm. Current flow is this. So bermakna apakah maklumat diberikan di sini memang sangat jelas lah. So apa yang berlaku? Pertama sekali diberikan kita adalah EMF is equal with 3 volt. Internal resistance small r 0.5 ohm. Then external don't know the value, so doesn't matter. Current flow I equal with 0.4 ampere. So soalan A, potential difference across the resistor. Bermakna dia nak cari apa? It's an external voltage. Do remember external also can be written as EMF minus internal IR. So iaitu 3 tolak 0.4 multiply 0.5. Calculator, you get 2.8 volt. Okay, same thing goes to question B now. They want you to find a big R. So V external is equal with IR. So this is 2.8. I is 0.4. So diminta carikan R. Same thing, it's very simple. R, just use a calculator, you can find it. It's 7 ohm. Alright? I think it's kind of simple for you. Alright? So that's all for this video. I hope you can understand how you use the formula. See you in the next round. Bye-bye. Stay strong, stay healthy. Hi. Ini merupakan last video I will say for the chapter number 2. And this video is to teach you how we're going to calculate energy based on the electrical tariff. Okay, atau tarif electricity. Okay, apa maksudnya? Kita akan lihat. So this is one of the example that I can get from the past year question. It's not in the notes, but it's okay. You just look at the screen will do. Table 12.1 show the detail of the electricity used by the 3 electric appliances in a household with a 240 mains power supply. Okay, dia menggunakan 240 volt lah. So jada 12.1 menunjukkan ciri-ciri penggunaan tenaga elektrik pada 3 alat elektrik di rumah, di mana bekalan saluran dia adalah elektrik adalah 240. Itu biasalah. Kita ada peti sejuk, refrigerator. As you can see, the usage is 1 kilowatt and be used for 24 hour. And the air conditioner, alat penyaman udara, 1.2 kilowatt. Used for 10 hour a day. And the washing machine is a 12 ohm dan menggunakan 2 jam sehari. Okay. Then the next thing they give it to us is called the electric tariff. That means that the charges. As I mentioned, normally, right, they charge like per unit. And according to here, the first 100 units, you have to pay for 20 cents per unit. For second 100 unit, you have to pay for 23 cents. More than that, they have to pay 25 cents. What it means by all these things, I will explain to you one by one later on. Okay, let's go back to the question again. Okay, question number 1. This is the question now. Alright, this is the question. So all this is the table I showed you just now. All this table I already showed you lah. So the total energy consumed in a day. Jumlah tenaga digunakan. So the money wise, the tariff one, I do not need that. So I move the table away first. So let me show you how to do that one by one. So let's start with the refrigerator. Okay, I called it as a simple one. 1, 2, and 3 lah. 3 alat. Okay, saya menggunakan pen yang lain mana pula. Okay, now for the first one, refrigerator, how it's gonna work? As I show you that the usage is basically is like using 1 kilowatt. You multiply by the time of your usage, which is 24 hour. So this is very simple. It's considered 24 kilowatt hour. So that's the energy usage for the first appliance. Alat pertama lah. Alat yang kedua pula adalah 1.2 kilowatt multiplied by the 10 hour. So obviously you will get a 12 kilowatt hour. As simple as that. Tapi alat yang ketiga dia memberikan kita ohm sahaja. But you need the power. We need to find the power first. If you remember previously, we know power is V squared divided by the R. So basically it's 240 square divided by the R. So according to the question they're giving us over here, okay, they're giving us over here is a 12 ohm, alright? It's a 12 ohm. So that means you can use a calculator to calculate this. You got 4,800 watt. But you have to understand that the calculation of the electric tariff, you must calculate in terms of kilowatt. So this is 4.8 kilowatt. Okay, and you use for 2 hours. So your usage gonna be 4.8 kilowatt multiplied by 2. So you will get a 9.6 kilowatt hour. Okay, not yet, belum lagi. So what's the total energy consumed in that day? Total energy per day. All right, so they're going to be 24 plus with 12 plus with 9.6. So basically we're just taking all the value that we have over here, just add together. Of course you can help with your calculator. You will get a 45.6 kilowatt hour, and that's the answer for this first part. Total energy consumed in one day lah. Okay, or you can say it's a 45.6 units. And what else they want? So just now we already find out. Okay, we already find out. Kita sudah dapati jumlah penggunaan sehari adalah 45.6 kilowatt hour. Okay, the next thing they want you to find out is a consume in 30 days. Kalau 30 hari pula macam mana? So I don't think this is difficult for all of you. So this per day is 45.6 kilowatt hour is per day. So we just have to multiply by 30 will do lah, 30 days. So multiply by 30, obviously you can use a calculator. So 45.6 multiplied by 30, you will get 1,368 kilowatt hour. Okay, so that will be your answer of your usage lah. So you can say that is basically is a 1,368 units. And lastly, how much you need to pay for that total cost. Now we're going to move on to the next question. As you can see here, the total cost. Okay, jumlah bayaran yang diperlukan. So macam mana kita nak buat? So just now we already know that your total usage basically is 1,368 units or kilowatt hour. Mengikut apa yang diberikan, first 100 units. So first 100 units, you have to pay for 20 cents. So 100 multiplied by 0.2. How much you have to pay from here? So basically it's very simple calculation. I don't think you need a calculator as well. So you will need to pay 20 ringgit for the first 100. But remember, you got 1,000 over. You already paid the first 100 units. So the balance of 1,268 unit need to pay. So according to the question, the next 100 unit, you need to pay for 23 cents now. So akan menjadi RM 23 ringgit. That is only now. You see, the balance is 1,268 just now. The first 100 you already paid. Kamu sudah bayar 100 unit yang pertama. 100 unit yang berikutnya, kamu pun sudah bayar 100. Bermakna balance 1,168. Dan mengikut apa yang diberikan, above 200. Bermakna apa yang lebih itu, kena bayar 25 sen setiap satu. So it's 1,168 multiplied by 25 cent. Okay, 1,168 multiplied by 25 cent. So in this case, you have to pay for how much here? It's RM 292. So what is the total payment that you need to pay per month? So total gonna be 20 ringgit plus with 23 ringgit plus with 292 ringgit. So you are kind of expensive as you can see here. Just 3 appliances only. Jumlah bayaran adalah 335 ringgit. Understand? So this is how we're going to calculate the cost of usage in your house. And that's all. And that will conclude the whole chapter number 2. Alright, that's all. See you again. Take care and stay healthy, stay strong. To all the Form 5 students, welcome back. So hari ini kita akan cuba masuk selepas kita belajar terhadap Ohm's Law, hukum So now we're going to learn about type of conductor, jenis-jenis conductor. Okay, for those who are using my notes, you can refer to the page number 7 of my notes lah. Okay, so let's carry on. So dari jenis bahan, kita sebenarnya boleh kategori kepada 4 jenis. Yang pertama kita namakannya sebagai insulator ataupun in Malay we call it penebak. Insulator or penebak. So what does that mean? So a lot of people actually has a misunderstand based on this type of material. A lot of people might say that, oh, insulator ataupun penebat adalah bahan yang tak boleh mengalirkan arus, cannot conduct electricity. Is that true? I would say not that. Okay, not that true. Sebab penebat bukan bermakna dia langsung tak boleh mengkonduksikan electricity, tetapi dia suka. That's why the proper definition is supposed to be material which has a very high resistance. Very high resistance means very difficult to go. Okay, rintangan yang lampau tinggi. Okay, rintangan lampau tinggi. Maksudnya apa? Dia sememangnya susah nak mengalirkan arus. Okay, that means that the resistance, you will remember about the resistance. So we know that resistance basically is a kind of difficulty of a material, okay, of the material to block the flow of the electron. So this resistance becoming extremely high now. Okay, extremely high. So it become very hard to move. So that is called an insulator. And obviously a lot of people know what is the example of insulator we can find. Alright, so it's like a rubber, wood, plastic. All this is considered as a insulator ataupun dinamakan sebagai penebat. So harap kamu boleh faham lah membezakan antara bahan yang pertama yang kita namakan di sini adalah penebat. Okay, insulator. Okay, next. Okay, of course Malay translation already on the screen. Ketak, kayu ataupun plastik. Of course, for those who are using my notes, please make sure that okay, you copy this down into your notes, your paper notes. Or you don't understand this, just you watch this again. Okay, hope you can help you. Okay, during this difficult moment. All right. Next thing we have is called a conductor, in Malay conductor. So what is a conductor? Obviously, everyone know. Conductor is a material with low resistance, rintangan yang sangat rendah. Okay, ingat, insulator sangat tinggi. Okay, conductor rintangan yang sangat rendah. Itu adalah kebaikan dia. Alright, and what else you have? And this is a very important criteria and character on it. Resistance is directly proportional to the temperature. Maksudnya apa? Maksudnya rintangan ini adalah berkadar terus dengan suhu. In Malay, you can see the translation is there. Maksudnya semakin suhu semakin tinggi. If you remember for the previous lesson, temperature high means that the vibration of the particle is getting stronger. So this will make the resistance of the material is getting higher, difficult to go. If the temperature is lower, okay, the vibration of the particle is getting lesser, the resistance definitely will reduce. Alright, so that is very important. And what kind of material got that kind of ability? Obviously, you know lah. This is what we discussed before, like copper, silver, gold. Because in Malay, they call it cuprum, perak, ataupun emas. So this is kind of simple for you, okay? Next type of material is called a semiconductor. So from the word itself, I think you know very well. Semi. Apa maksudnya semi? In Malay, semi also is translated into semi. So that's why in English, some people pronounce a semiconductor, some person pronounce a semiconductor. So it doesn't matter for the pronunciation. So semi or semi means what? Half, separuh. So what do you mean by semiconductor? Remember, conductor means low resistance. Insulator, high resistance. So semiconductor, something in between. It's so-called okay lah. So material has a resistance in between insulator and conductor. Di antara penebat dengan konduktor. Maksudnya apa? Ada kadar rintangan tinggi? Tak sangat. Ada kadar rendah? Dia pun tak sangat. Dia merupakan satu bahan yang memang istimewa. Okay, kita akan belajar dengan lebih teliti semasa kita masuk kepada bab yang keempat. Okay, electronics. We will learn in more detail about it. They are special because the resistance in between. Okay, so that means in between means what? The resistance is lower than insulator but higher than conductor. Remember that. And this material have a reverse behavior. They have a inversely proportional. Maksudnya apa? Resistance is inversely proportional to the temperature. It means that when temperature rise, this resistance actually getting lower. On the other hand, this one getting lower, this one getting higher. This is very, very special behavior. So why they behave that way? Mengapa dia mempunyai sifat sedemikian? Of course, I will teach you, I will tell you when we come to chapter number 4. So now, I'm very sorry, I'm not going to tell you now. So, but I will promise you, I will tell you during chapter 4. Saya janji kepada anda, saya akan beritahu kamu mengapa dia sedemikian semasa bab yang keempat. Nah, apakah bahan yang membuat sifat sedemikian? Tak lain dan bukan, dia adalah bahan daripada kumpulan 14 daripada jadual berkala, periodic table, group 14. Ladies and gentlemen, can you give me an example of group 14? No need to waste time. I know you don't know. It's fine. We have silicon, germanium. Okay. Of course, we know that in the group 14, the first atom in the group 14 is carbon. But carbon is not a semiconductor, but it's a very good conductor. Okay. Some student they message me, they DM me, they say, sir, since carbon is a conductor, why not we make it as a wire? Why we don't use it as an example of wire? We can't. Because carbon, right, is brittle. They cannot bend. Dia tak boleh dibengkokkan, dia keras. Dia conductor baik tapi dia keras. Kalau kamu dah buat wire menjadi batang wire dah. So tak sesuai. Understand? And the last one we have is called a superconductor. In Malay translation, what to do? We still use back the word superconductor. So from the word itself, you know, as I always say, physicists is very straightforward to the word that we use. Conductor, low resistance. Superconductor, very low resistance. Yes, you are right. Terlampau rendah. Maksudnya apa? Rintangan dia boleh mencapai lebih kurang 0 ohm. Iaitu current dianggap sebagai mengalir secara maksimum. That means that the electron basically can flow easily. Just imagine, as I told you before, let's say a wire. Just imagine you got 1 million of electron here. They flow in a superconductor. So how much you will get from here? Okay, maybe you will get the 0.99999 of the million, maybe. Okay, you will get almost what you have. So this is the idea of it. Okay, this is the idea of it. Okay, this is called a superconductor. They have a very low resistance. And in order to achieve a superconductor, one criteria, satu perkara penting, itu suhu mesti mencapai 0 Kelvin. Or we know that 0 Kelvin basically is equivalent with negative 273 degree Celsius. Bermakna dia merupakan satu suhu lampau rendah, barulah kamu boleh mencapai satu tahap superconductor, iaitu rintangan yang lampau rendah. So, apakah bahan yang boleh mencapai suhu rendah itu? So, we have the only one and only example that we can give it to you is called the mercury. Because mercury is a liquid metal. Dia merupakan logam berbentuk cecair. So, dia sesuai digunakan di sini. Understand? So that is the part that we need to tell you about this. So I will see you in the next video. Hope you can understand what I taught you today. Thank you very much and stay strong, stay healthy. Hi everyone, welcome back. So now I'm gonna enter a new subtopic. We're still in the chapter number 2 lah. Masih dalam bab yang kedua. But for this part, you have to use a new set of notes, okay? The previous one is already finished, okay? Which is the last part is called the type of conductor. Itu sudah habis. Ini kena rujuk nota baru. So where you can get the new set of notes, or you can download it from where? From my Telegram. So please join my Telegram channel. Okay, what is my Telegram channel? You can go to my blog to find the channel link over there. If you really don't know what's a channel link, please message me in the Instagram. So I will share you the link lah. Kalau boleh, I don't know whether you can share a link or not because I know Instagram cannot put a link there. It doesn't work. So please lah, okay, please join my channel, then you can get the notes from there. Okay, or if you don't know, you can go to my blog. There's a link over there. If you don't know my blog, you can message me through my Instagram as well. All right. So without further ado, let's look at it. So, okay, this is what we call as a series circuit. Series circuit actually referring to the circuit by using one wire connection. As you can see from here, very obvious. I use a red pen. I change my pen color. You can see how we're going to know about it is basically this is a positive terminal, this is a negative. If you can see the current, right, if it's coming out from the positive, they go all the way in one complete round to the negative. That is what we call as a series circuit. Series circuit, basically you can see that the current actually is moving in one direction, or I would say one way only. So that is mean by series circuit. If you use more than one way ataupun lebih daripada satu cara, kita namakan sebagai selari parallel. Understand? This I'm going to talk about it later on, not here lah. So this is why I tell you is about series. Dalam series circuit ada beberapa perkara baru kamu tahu. So this diagram actually is already in your notes. So please refer on that. So I will share with you is the formula that you need to know based on the series circuit. So I will share with you in the next slide. So please copy it down into your notes. So that's why it's good for you. You have notes and you have be able to print it out. Kalau tak boleh, it's okay. You just write on a piece of paper. Once we come back to normal, so I will give you the physical notes. You can copy it back lah. Okay, so let's look at the next one. Apakah formula penting? So dalam satu series circuit, so there's a, let's say there are 3 resistor over here. So resistor maksudnya perintang. So you can see there's 1, there's 2, there's 3 resistor over here. Okay, dinamakan sebagai, they call it as R1, R2, and R3. So apa yang kamu perlu tahu? First of all is the current. Let's talk about the current flow. So the current flow actually in the first resistor, and a current flow in the second resistor, and a current flow at the third resistor, and even the current flow from the supply, yaitu arus mengalir dalam sumber, yaitu battery. Basically, they are all the same. Oops, sorry. Basically, they are all the same. Okay, semua adalah sama. Basically, they are all the same. Okay, bermakna current flow in the first resistor, R1, and the current flow in R2, and current flow in R3, semua adalah sama. Katakan R1 is getting 1 ampere, R2 also 1 ampere, R3 also 1 ampere. But in terms of voltage, okay, voltage 1, voltage 2, and voltage number 3, and a voltage supply. Okay, apa yang berlaku? Basically, we find out is a plus. Bermakna voltan-voltan dicampurkan mesti sama dengan voltan bekalan. Okay, maksudnya adalah dalam satu liter, katakan voltan bekalan adalah 12 volt. So 12 volt ni akan dikongsi bersama oleh 3 rintangan. Dan apakah nilai voltan masing-masing? Itu terpulang kepada keadaan. Maksud saya adalah you don't think that it must be 12 volt, it must be a 4 over here, will be a 4 over here and 4 over here. Not necessary. Yang penting di sini adalah ketiga-tiga dicampurkan mesti 12. Tidak semestinya dikongsi pada nilai yang sama. Boleh juga katakan R1 dapat 1 volt. Katakan R2 dapat 2 volt. Katakan R3 akan dapat 9 pada keadaan itu. Yang penting dicampurkan dia mesti sama dengan 12. Itu maksudnya. Okay? And next one of course is the resistance. Resistance number 1 plus with the resistance number 2 plus with the resistance number 3, kita namakannya sebagai satu total resistance. Jumlah rintangan. Okay, a total resistance. Okay, maksudnya adalah, katakan rintangan pertama adalah 1 ohm. Excuse me. 2 ohm yang kedua, 3 ohm. So, apakah jumlah rintangan? Campurkan sahaja. Sesiri memang senang, campur terus dapat 6. Okay. Then one more thing is, as I mentioned previously, voltan untuk setiap satu bahagian sememangnya adalah bergantung. Tidak semestinya 4 ataupun 4. Dia terpulang kepada keadaan. So, macam mana kita nak tahu nilai sebenar untuk voltan masing-masing? So, we have a special formula for it. Remember, I'm going to give you a special formula. Special formula ni ada macam ini. Apabila kamu diminta carikan voltan pada perintang yang pertama. So, what you need to do? The formula is this way. You just have to take the resistance at the first one. Of course, it's respectively ya. Kalau ini V2, ini pun R2 lah. Kalau ini V3, ini pun R3. Bahagi dengan total resistance, jumlah rintangan. Lepas tu didarabkan dengan voltan daripada battery, itu supply. So that's a special formula. Later, when we have a chance to discuss some of the question, I will show you lah how it's going to work. So let me show you some basic question how they may ask you in the exam. Let's look at the next slide. So this question you can find from the notes. Kamu berjumpa di nota anda. Okay, jelas kita nampak ini merupakan satu sambungan yang sesiri. Yaitu from X, this point up to this point, you are using, you can see all the way, it's only using one wire. So untuk mendapatkan total resistance for this, it's just simple. You just take the 2 plus with the 5 plus with the 3 plus with the 10. So this come to, how much it gonna be? Yes, you are right, 20 ohm. That's all. Simple. Series circuit memang senang. How about this one? Same thing. Kamu boleh nampak dari positif terminal kepada negatif yang merupakan satu litar sambungan saja. Tapi sekarang dia bukan minta kamu carikan jumlah rintangan. Dia nak carikan current. The current is how much from here. So how we need to do? So first of all, we need to find out the total resistance first. Disebabkan this a series, so it's a 6 plus 12. You akan dapat 18 ohm. Dan untuk mendapatkan I, current, we know one formula that we never forget in the whole life. It's called V equals to IR. So diberikan V adalah 9. So the I, we do not know. But the R, we already found is 18. Why I'm doing that? Sebab ini adalah 9 volt daripada bateri. Bateri ini adalah bertanggungjawab untuk whole circuit litar. So remember, setiap kali kamu masukkan nilai dalam bateri, you have to put a total resistance value. Okay, remember that. So when I see you again, I will explain more detail on you lah, with you, sorry. So the current gonna be 0.5 ampere. Itulah jawapannya. Okay, let me show you another one so that you understand better. This also you can find from the notes. Same thing lah. So apa yang kita kena buat? So first of all, kita boleh gunakan V equal to IR. Remember, I'm going to plan to put this thing inside. Ini merupakan satu sumber di mana kamu boleh nampak juga sama, dia merupakan sambungan 1 litar sahaja. So kalau sambungan 1 litar, dia adalah litar sesiri. Apabila saya cuba nak masukkan nilai ini, R yang saya akan dapat automatically will become a total resistance. So 240 adalah sama dengan 6 ampere total resistance. Di mana total resistance adalah dapat 40 ohm. Then you will see that this circuit come with 2 resistor. So means R plus is a series 20. It's going to be just a 40 ohm. So how much is the R? Very simple, right? Just a 20 ohm. So that's the answer. So that is how the series circuit is going to work. Okay, I hope you can understand it. So, in the next video, saya akan cuba bincang dengan anda tentang litar selari parallel circuit. Okay, so that's all for this video. Okay, hope you can understand. See you next time. Stay strong, stay healthy. Everyone, welcome back for today's lesson. So now this is another circuit that I'm going to discuss with you from the previous one. Previously, we have a series circuit. Now we have a parallel circuit. In Malay, kita namakannya sebagai litar selari. So again, this is referring to the new notes, page number 3. So make sure you download the notes either from my Telegram, alright? Sorry, only Telegram have that notes, yeah. So what is my Telegram? You can go check it out in my blog lah. Okay, so let's progress with today's lesson. So what is happening here is, okay, what is the difference between series and the parallel now? Okay, as you can see from the diagram, okay, parallel circuit basically is a circuit using more than one wire. Okay, what I mean by that, you can see from the diagram itself. You see, if you are comparing with the series circuit, if you are comparing with the series will be, you can see there's a battery, then you can see there's a connection, the wire connection. So they connect, then they will connect with one resistor, then it might connect back just like this. So you can see that this whole wiring, okay, is only using satu dawai sahaja. So ini ada dinamakan sebagai series circuit. Dia menggunakan satu, okay, cantuman satu wire sahaja. Okay, kalau kamu boleh nampak seperti yang kita tunjuk di sini, this more than one wire as you can see from it. So this is a positive and this is negative. You can see apabila current dikeluarkan sampai ke sini, when it come to here, there are 3 cabang. So there can be 1, there can be 2, there can be 3. So there are 3 loops over here. So ini dinamakan sebagai parallel circuit selari. And of course, obviously you can see the loop will come back and combine again and join back to become the negative. So do remember that that's the difference. So as a simple conclusion, I would say that if you can see the circuit with only using one wire, it's called series. And if you use more than one wire, it's called a parallel. And do remember, because you are Form 5 student, please do not influence, okay? Influenced by the wire connection. Jangan dipengaruhi oleh susunan wire. What I'm trying to say is that if there's a battery, for example, if the battery coming out from here, the wire come out, maybe the wire go, turn, spin here and there. That is one resistor, just like that, it go back to here. So what type of circuit is this? It looks so complicated, but actually not at all. Sebab dia menggunakan berapa wire? Satu wire saja. So this is what we call as a series circuit. Okay? If what happened is, if this wire, you add another one, okay? Yeah, another one. For example, from this resistor, or even somewhere else, I just add another one just beside this. You can see that I'm using two wire now. One wire is a white, one wire is a red. So I'm using two wire now. So this kind of circuit is considered as a parallel. Alright? So that's the biggest difference. So same thing, in order to understand the series and parallel, there's a list of formula. For series, you know that there's a 4 important formula that we have. So for parallel, will be the same thing. There will be 4 formula as well. Okay, let's look at the next slide. Let me show you what is that. Okay, first of all, okay, if you still remember for the series circuit, the whole circuit current is the same, but voltage is a plus. So parallel circuit will be the other way around. What I means, okay, yang pertama, di tasa series, dia mempunyai current sama, voltage dia tambah. So for parallel, voltage dia equal. Okay, you may write down into your notes, the voltage actually is equal. Even the same with the voltage from the battery, you call it voltage supply. Sememangnya sama. Voltage dia mesti sama, di mana-mana saja. Okay, number 2, okay, is based on the current. Previously from series, current is the same. So this one, current is a plus. Okay, kamu cantumkan semua current yang mengalir dalam meter, dia akan sama dengan current daripada power supply, iaitu battery itself lah. Okay, itu maksudnya. Same thing. Okay, what I'm trying to say is, for example, katakan I have, let me change the pen color so that you can see the difference here. Alright, so apa yang berlaku, katakan I have a 1, I have a 2, then I have a 3, for example, connect together. Then let's say this is a battery connection, just like that. So apa yang berlaku, katakan, okay, di sini adalah menghasilkan 12 ampere. It doesn't mean again, it must be 4 ampere, 4 ampere, and 4 ampere each. Adakah sedemikian? Tak semestinya. Okay? So one thing for sure, you add up here, it must be 12. That's all. So apa nilai dia can be anything. Maybe this is 2 ampere. Maybe this is 4 ampere. So at the end of the day, it must be a 6 ampere here. Total must be equal with a 12. That's the key point. Alright? Next. Later I'll show you some example lah. Then you will understand better what's going on. Okay, formula yang ketiga adalah terhadap resistor. Yang ini dia agak berbeza sedikit sebab dia punya adalah susunan dia adalah 1 per R1 campur dengan 1 per R2 campur dengan 1 per R3 sama dengan 1 per R jumlah total resistance. Sorry, there's some mistake in the software. So itu adalah formula dia. Dan formula terakhir yang keempat, if you remember, for the series circuit kita ada satu formula yang khas digunakan untuk voltage. Ini formula khas digunakan untuk cari current. Just like this. How we know what's the value of this current and this and this? How we know all those value? Macam mana kita boleh tahu? So sememangnya kita ada formula. Formula dia adalah, kalau untuk series circuit, is R1 over R total. If you remember, R1 di atas, R total di bawah. Ini songsang. R total di atas, R1 di bawah, multiply with current from the supply. Itu adalah formula dia. Okay? So make sure you copy down into your notes. Okay, I'm going to go on to the next slide. If you cannot copy now, you just pause the video, then you can copy yourself later. Alright? Tengok latihan, page yang keempat. Okey, jelas kita nampak ini merupakan satu susunan selari. Okay, parallel. Why I can say that so? Because you can see the wire from here. They got one wire here. There's another wire go this side. So it's a parallel. Kalau parallel circuit, nak dapatkan total resistance, basically is 1 over 5 plus 1 over 20. Okay, ingat, when you do that, please do not do a stupid thing that turn everything around like that. Jangan, tak boleh. Ini kena hasilkan menggunakan cara pecahan. Don't turn it. You can't turn it. Okay, you can't turn. Okay, please remember that. Okay, so you have to solve it by using a fraction method. Okay, now what you're going to do? So basically, just do a fraction, pecahan saja. So ini akan menjadi 4/20 campur dengan 1/20. Kita akan dapat 5/20 iaitu 1/4. So you will see from here is 1 over total resistance adalah 1/4. Sampailah tahap ini barulah kamu putarkan dia. Then only you can turn. Don't turn during the beginning. Beginning you have to do in a fraction form. So the total resistance will be becoming 4 ohm. So this is how we do. Okay, so you can see one thing for the parallel circuit. Remember that parallel circuit, right? When you try to add up like 5 ohm and 20 ohm like this, so you can see 5 and 20. When you add up together, you only get a 4. But if you try to connect this in series, secara bersiri, you get 25 ohm. Secara kesimpulan, I want you to remember, series circuit, right, akan mempunyai satu rintangan, jumlah rintangan yang sentiasa lebih besar daripada parallel circuit. Always remember that. Parallel circuit actually lower resistance. Series circuit is always higher resistance. Is it okay? Let me show you one more example. You can see on the next one. Same thing, very, very obvious, everyone. One wire here, another wire forward, another wire bottom. 3 wires over here. Parallel circuit. So same thing, we're going to do some working here. 1 over total resistance sama dengan 1 over 2 plus 1 over 5 plus 1 over 10. So kita cuba carikan, okay, yang sepunya, iaitu darab dengan 5 per 10 campur dengan 2 per 10 campur dengan 1 per 10. In the end of the day, dia akan dapat 8 per 10 iaitu 4 over 5. So same thing, remember 1 over total is just 4 over 5. In order to get the final answer, putarkan pada step terakhir, total resistance becoming 5 over 4. Okay, so you can leave it in term of fraction, tak ada masalah. Okay, kalau you tak nak, you boleh buat dalam bentuk perpuluhan 1.25 ohm. So that's the answer. Same thing, you see, kalau kita cuba cantumkan secara bersiri, maksudnya apa? Imagine one resistor, 2 and 3. Okay, setiap masing-masing you can see this is a 2 ohm, for example. This is 5 ohm, and this is a 10 ohm, for example. If you add it up in series, you get how much from here? You get 17. But if you do in a parallel, kamu akan dapat 1.25 ni. So series is always higher resistance than a parallel. Understand? Okay, so I think I'm gonna stop here. So I hope you can understand this. So in the next video, I will show you what will happen when a series and parallel combine. Apabila kita cantumkan secara bersiri dan selari dalam satu litar, macam mana kita nak buat. Okay, so see you in the next video. Bye. Hi everyone, welcome back. Okay, hari ini saya akan tunjukkan kepada anda macam mana soalan jika ada gabungan antara litar sesiri dengan litar selari. So I'm going to show you some example of question that involve a series and parallel together. So from the previous lesson, I already showed you how to do a series and also parallel. So now I'm going to show you when they are come together in one circuit, how we are going to calculate. So I'm going to show you and teach you by using example. So let's look at it. So this is the question actually you can find from my notes on page number 4. So obviously you can see that this is a combination of a series and parallel because you can see from here. From here to here is obviously, and then the one wire, here is another wire. So it's a parallel, and when they combine together to become one wire back, so becoming a series. So what we can do now is we combine. The first step we're going to do is we're going to combine the parallel part first, which is the 1 over 20 plus with 1 over 20. So you will get a 2 over 20. Oops, sorry. So you will get a 1 over 10. But do remember, this calculation is only involved and referring to 1 over total resistance. So that means it's 1 over 10. So in then, the total resistance just has to flip over this thing. You're going to get a 10 ohm. Okay, I think it's not difficult. Maksudnya adalah sekarang litar ini akan menjadi satu litar baru yang seandainya adalah satu perintang yang bernilai 10 ohm. Okay, 10 ohm yang kita ada. Dan lagi satu 10 ohm yang sedia ada dalam soalan lah. So you can see from here. So bermakna apabila kamu gabungkan di sini, ini adalah 10 ohm. Dan satu lagi 10 ohm ada datang daripada sini. So sekarang kamu boleh jelaskan, nampak here to here is a what circuit is that? Yes, you are right. It's a kind of series. So series circuit is very simple. Just add up only 10 plus 10. So you get a 20 ohm. So that's all you have to do. So let me show you more example. Next one. As you can see from here, here is one wire. Here is another wire here. So there are two wires now. It's considered as a parallel. But in the top wire, you can see there's 1 and 2 connected in the same wire. So this part is considered a series. So it's a 5 plus 5 equivalent with 10 ohm. So that means litar ini akan menjadi satu litar yang seandainya di atas mempunyai satu lintangan tunggal bernilai 10 ohm. Di mana di bawah juga merupakan satu lintangan yang tunggal tetapi 5 sahaja. So jelas kita nampak ini adalah satu litar selari. Kalau selari 110 plus 15. So you will get a 310. But this is not the answer. Remember, because this 310 is just a 1 over total resistance. 3 over 10. Instead of get, excuse me, you get a total resistance. Basically, it's just a 10 over 3. Just flip it up only. That's all you have to do. Alright, simple one. Next. This one look very complicated, but don't worry, it's not that at all. Okay, basically it's like this. So first of all, on top you can see there's one wire, another wire here. Two wire parallel, connect back, series. So maybe it look very confusing. So what you can do, you can try to redraw the entire thing becoming like this. Wire coming out, go upward, nilai dia 5 ohm. Lepas tu 5 ohm, disambung secara terus. This part is one wire connection. Don't affected and influenced by the wire. Is one wire. So bermakna, come back to here. Another 5 ohm. Bawah pula, same thing. 5 ohm, 15 ohm. Connect back. This is the 5 ohm. This is the 15 ohm. Okay. And connect back, join out, another 8 ohm. So what you can do on top, combine the one on top is a series, 10 ohm. Combine the one below, becoming 20 ohm. So ini akan menjadi satu litar lebih ringkas, yaitu on top adalah 10 ohm. Bawah pula ada satu nilai tunggal 20 ohm. Alright, dan come out from here is a 8 ohm. Okay, so as you can see, this and this is a parallel. So 110 plus 120. So here dapat 320. Remember, this is not the total yet. So the total resistance is a 3 over 20. Flip over. So R total menjadi 20 per 3. So kalau kamu buat dengan titik perpuluhan, it will be very ugly. So I leave it as a fraction. Dan setelah digabungkan, kamu akan dapat dia menjadi satu litar series. So the final answer of the total will be the 20 over 3 ohm plus with the 8 ohm outside. So you will get how much from here? You get a 44 over 3 ohm. Itulah jawapannya. Or you can say it's a 14.66666 lah. Or 14.67. Okay? Another example to share with you, like this. Same thing, what you gotta do? I think you got use of it. So with this and this combine. So 15 plus 120. Okay, dia akan menjadi berapa di sini? So you get a 5/20, you get 1/4. So ini menjadi 1/, total resistance adalah 1/4. So total resistance akan menjadi 4 ohm, flip over. Okay, so tapi di luar ingat ada satu lagi 1 ohm. So the final total resistance is 4 plus 1, you get a 5 ohm. But not yet. Soalan minta carikan apa? You can see the question carefully. They ask you to find this. So you want to find the voltage from the supply, as I told you before. You can use a V equal with the IR. Sorry, there's a mistake here. So disebabkan ini V ada daripada sumber, bermakna as I told you about the previous lesson, the R must be a total resistance. Okay, sumber total resistance. So sumber tak tahu, tapi I adalah 2 ampere, total resistance 5. So equivalent with 10 volt. So that's the answer. Is that okay? Kinda, I think a rough idea what's going on. So there, of course, there are more example exercise in the notes. Can you please complete it? Okay. I will see you again. I will discuss with you when we meet up each other after the MCO is over. Okay, take care everyone. Stay strong, stay healthy. Hi. Okay, so this is considered the last part of the chapter number 2. So this is considered done for the Form 5 chapter number 2. I hope you can benefit all of it. So apa yang berlaku di sini adalah, so ini adalah sebenarnya satu video yang giving you an idea of the conclusion of the energy that we need to know. So what it means, let me show you by using this. Okay, first of all, we know that electrical energy, the formula for the electrical energy is called the VQ. So that is a general idea for it lah. Okay, electrical energy, VQ. And this formula actually can be modified in many ways. For example, let me show you now. So because the Q is equal with IT, okay, equal with IT, that's why electrical energy also can be written as VIT. It can be another formula. So this is not a new formula, I would say. It's just a combination of the formula inside only. What else you have to know? We also know that V is equals to IR. So apabila saya gantikan masuk ke dalam, so E menjadi IR IT. So if I try to simplify it, it turns into I square RT. It seems like another new formula. Like this is the one, this is the one, there's another one here. Am I right? Not only that. So one more time, E equals to VIT from, oops, sorry. Okay, E equal VIT. So what is happening? Just now we already know V is equal with IR. Betul tak? So can I say I is equal with V over R? Right? So I can substitute inside here. Ganti ke dalam. So menjadi V over R T. Dia akan menjadi apa? V square over RT. Nampaknya satu lagi formula yang baru. Not only that, let me show you more. One more time. Energy basically is VIT. Alright? So sekarang this formula boleh menjadi apa? Boleh menjadi I square RT. Juga boleh jadikan apa? V square RT. Alright? So dah ada banyak bentuk dah sekarang. Not only that, we also know power is equal with any energy divided by the time. So that means the power can be written as all the one above just without a T. Power is VI. Also, I square R. Also, V square over R. You can see ada banyak bentuk kita boleh tuliskan untuk dia. Understand? You will feel like, wow, there's so many formulas. Actually, it's not at all. All this formula came from the basic one. What is the basic? Energy is VQ. That is the basic. So the all actually is a combination of this with these two only. Okay. Another energy calculation, if you know, is what we call a tariff. Okay, what I mean by a tariff? Okay. Tariff actually is referring to the charges for the electric energy supplier. Mean charges for the power supply. Okay, power supply charges. Okay, In Malay, these charges here is called CAJ, charge, because talking about money now. In English, charge actually got two meaning. One is really is a charge, one is actually referring to the money. That means that how they charge you money, like TNB, how they charge you money. So the tariff that we use in the whole world will be the same. How they charge. When you try to observe the electric meter in your house, you can see there's a number. Every number is representing one unit of usage. Satu unit. Satu unit sebenarnya mewakili apa? Dia mewakili 1 kilowatt hour. What I mean by 1 kilowatt hour? That means you're using 1 kilowatt in the time of 1 hour. That means that basically you can imagine TNB charges electric bill by hour. It's not by second, okay, luckily. So what I mean by 1 kilowatt per hour? That means it's 1,000 watt of usage in 1 hour of time. Okay, that's what I mean by that. And that's called the energy usage. So the tariff means actually the money. The money depends on the question and depends on the country. Biasanya, satu unit dia akan memberi, one unit normally they will charge you is around, like for example 20 cent. So bermakna kalau kamu pakai satu unit, you kena bayar 20 sen lah. Itu maksudnya. So how is it going to work? Of course, there's a not to say very complicated. There's a list of calculation you have to use and work out with that. So I will show you in the next video how we're going to calculate this tariff lah, means the money. And this is the only subtopic for your information in our syllabus that involve money. Okay, so I will continue in the next video. That's all for today. And for this video, stay strong, stay healthy. Hi everyone, welcome back. So today we're going to enter another subtopic we call Ohm's Law, hukum Ohm. Kalau kamu lihat kepada buku kamu ataupun buku nota anda adalah merujuk kepada buku surah ke-6 lah, page number 6. Okay, I called it as Ohm's Law part 1 because long story we need to talk about Ohm's Law. So I separate into 2 videos, okay? If the video is too long, I don't think you like to watch it, right? So ini adalah bahagian pertama lah. So mari kita masuk apa maksudnya Ohm's Law. I hope you don't bother by the background music because I'm playing some song at the back. I don't know whether you can hear it, but I like the song so much. It's from Sinar Majid. Okay, come back to this. Ohm's Law, hukum Ohm. Okay, that's the definition. The complete long definition, okay, definisi yang panjang kamu boleh lihat pada nota anda. Tapi idea utama untuk yang ini adalah dia mengatakan apa? Current is directly proportional to the potential difference in the conductor. Okay, arus adalah berkarya terus dengan beza keupaan dalam satu conductor. Maksudnya di sini adalah, it means current I is directly proportional to the voltage here. Okay, what it means by this statement over here? That means that the current, right, when the current is getting bigger, directly proportional. Maksudnya apa? More current, arus yang lebih banyak, kamu memerlukan lebih banyak voltage ataupun beza keupayaan or potential difference. On the other hand, when you have a less current, you need less voltage for that. So that is the main idea of the Ohm's Law. Ini adalah idea utama dia. Tapi apa maksud sebenarnya? Of course, I will discuss with you later. Bukan begitu saja. If you look at the definition, they still also mention that the physical condition is to remain constant. Keadaan fizikal adalah mana. So apa maksudnya kenyataan ini? So semua yang cuba saya nak terangkan di sini, saya boleh guna satu slide yang mudah to explain it to you. So sebelum kamu nak kena faham terteliti dengan apa maksudnya Ohm's Law, you need to understand these 3 simple and basic things first. It's what we call as a charge, current, and potential difference. For those who are in my class, obviously everyone here is in my class. You know that I always like to use an example to explain to this. It's what we call as a T and B. Okay, ingatkan apa maksud di sini. Okay, pertama sekali, apakah TNB sedang lakukan? As I always say, TNB actually is a company with generating all the electrons. Okay, they are just an electron producer. They're producing electron. Lepas tu, what they will do? Okay, this electron is with what we call as a charge. So they will group the charge together. Dia akan cuba bungkuskan dia menjadi setiap bungkusan. Setiap satu bungkusan dinamakan sebagai satu column. Di mana kita tahu one column is containing how many electron inside? 6.25 times 10 power 18 of the electron in one group. Alright? So, satu bungkusan lah. Okay? So, ini dimaksudkan sebagai charge. Is what we call as a Q. Is what we call as a Q. Okay? Q merujuk kepada charge. So, this is the idea of it. Charge. Understand? Tetapi kamu kena ingat, charge hanya berlaku, hanya ada di TMB. Only TMB have it. But remember, our house, do I need the charge? Yes, because the charge gives us electricity. But how is electricity going to generate? So let me change the pen color so that you will see a better idea of it. Let me use a red. So apa berlaku adalah macam ini. So bayangkan dan contohnya adalah when the charge is moved from TMB to your house. So that will be a what? That will be a flow of charges. Dia merupakan satu pengaliran charge. Apabila pengaliran charge berlaku, dia akan menghasilkan satu benda dinamakan sebagai current, I, ataupun electricity. So, itu adalah idea untuk current lah. Tapi kena ingat, electron merupakan satu objek. It's a kind of object. In order to move electron from one place to another, you need energy. So, I use another different color pen to explain it to you. Okay, let me use the blue. So, dia memerlukan tenaga. So, tenaga untuk penghantaran ini berlaku ke sana, ke situ, dinamakan sebagai a voltage. Okay, a voltage, a V. So, now you can see logically lah. Kalau kamu memerlukan lebih banyak charge, kamu perlukan apa? Maksudnya apa? You got more flow, more current. But you understand, in order to get more current, kamu untuk hasilkan lebih banyak current, that means you need more electron, right? Logically, untuk buat penghantaran ini, voltage diperlukan mesti lebih tinggi, right? Am I right? Because you need more charges, more electron to move from one place to another. So, more electron need more energy lah. If less flow, flow is lesser. Okay? So, you need lesser energy to do that. You know what I'm trying to say? So, that is the idea of the Ohm's law. Current directly proportional to the voltage. Current berkaitan terus dengan voltage. Tetapi, on top of that, you must understand, that is the main idea. Kalau kamu cuba lihat kembali kepada definisi dia, dia menggunakan satu perkataan conductor. Okay, conductor. Okay, that's why you can see on the next one. I want to show you again. So, dia menggunakan satu perkataan namanya apa? Okay, let me change back the color of my pen. Oops, sorry. So, dia menggunakan satu perkataan namanya conductor. This is not the slide. Okay, conductor. Okay, maksud di sini adalah kamu boleh lihat, conductor means what? A wire. That means that basically, right, apa yang cuba dicadangkan oleh Ohms adalah apabila kamu bergerak dari satu tempat ke satu tempat. Okay, elektron nak bergerak, electron need to move. Electron is a particle, is an object. Semasa dia bergerak, dia memerlukan satu medium penghantaran. They need a medium. So here, they need a medium. Okay, this particular medium, okay, that we need to use is called the cable. Okay, or we call it as a wire. Alright, but do remember one important thing. Cable or wire, right? Okay, cable and wire that you must have is the one to link together. Let me go back. Between the TMB and your house. This is how they link. It means that you need a cable, a big cable, okay, to link together between this TMB to your house. So that is the main idea of it. Itu maksudnya conductor di situ. So dia kata, apabila kamu nak penghantaran berlaku, kamu memerlukan conductor. Okay, dan conductor itu mempunyai physical condition constant. What do you mean by physical consider constant? Keadaan fisika dia malah. This is a very nice thing, I tell you. According to Mr. Ohm said, when you use the cable or the wire to link two places together, number one, he promised you that the length of the cable, okay, the length of the cable must be constant. Maksudnya apa? Apabila kamu menggunakan satu kabel, panjangnya 1 meter. Hari ini 1 meter. Esok, berapa panjang? 1 meter. What like that? Ohm said. Dia promise. Itu maksudnya physical condition remain constant. Okay? Oops, sorry, this is a video. It's a public one. I cannot use the word I like to use all the time. Boo something. Okay. Of course, it sounds so boo. Okay. But it's true, okay? So, length must be constant. Number 2, dia kata size must be constant. Maksudnya apa? Ketebalan kabel mesti sama. Maksud dia, kabel itu tak boleh pemanjang, dia tak boleh berkembang. Maybe you say, sir, apabila dia panas, dia cuaca panas, dia kabel memanjang kan? No. Di sini maksudnya, kabel sendiri tak akan memanjang. Kabel sendiri tak akan membesar. The cable itself will not getting longer, it not getting bigger. It will be same. Of course, you may say, of course must be the same. Yeah, it is. But what to do? Ohms is the first person to say that. So you got the name. Not only that, temperature must be the same. That means the cable will not get hot and get cold by itself. Sendiri ya. Lastly, material. These 4 things. Material. Maksudnya apa? Today, you use the cable is a copper cable. Tomorrow, copper. Day after tomorrow, copper. It sounds so, sorry to say, bullshit, right? But it's true. He's the first person to say that. And it bullshit haven't end. Sorry, I say again. Very sorry. When your wire, all your wire can do all these things, then your wire can be categorized as ohmic conductor. Conductor ohmic. What mean ohmic conductor? It's a wire that obeying Ohm's law, mematuhi hukum Ohm. Maksudnya apa? It means your cable, the length, the size, the temperature, and the material never change. Obviously, we say, sir, all wire going to be like that. Yeah, all wire going to be like that. But this kind of wire is called ohmic conductor. If let's say you're using a wire, I don't know when, I don't know how, you found a wire. Hari ni kamu guna, dia 1 meter. Esok tiba-tiba jadi 2 meter. It's getting longer. That kind of wire is considered non-ohmic conductor. Bukan ohmic. Sebab dia memanjang. Same thing. Tiba-tiba kamu guna wire hari ini is a copper wire. Tomorrow the copper wire turning to gold. That is called non-ohmic. In terms of physics, in terms of Mr. Ohm, that is not good. That's not good. Ohmic means today copper, tomorrow copper. If you're today copper, tomorrow gold, not good. It's non-ohmic. Understand? But personally, for me, non-ohmic is more interesting than ohmic, right? But what to do? We are learning ohmic. We're going to respect him. Understand? So the more about the ohmic, I will continue with you in the next video. So I will stop here first. I'll see you in the next video. Bye-bye.